So hello and welcome everyone. Welcome back to my channel. This is the fifth video of our AI Builder series, and today we are going to start with an important topic, Depth First Search. It is a type of uninformed search algorithm, and today we'll be exploring this algorithm. But before starting, make sure you subscribe to the channel. So if you have subscribed, let's get started. So by definition, depth first search is an algorithm used for traversing a tree or a graph data structure in a depth-wise manner. Meaning, first of all, it will start with a branch and keep on exploring that branch till the branch ends. And after that, the next branch would be traversed. The next statement says the same. DFS explores as far as down a branch as possible before backtracking. So if it reaches the end of a branch, then it backtracks. Backtracks for what? To explore other sub branches of the same branch, or if it has traversed a branch completely, then the next branch. So that's what the definition means. So the data structure that it uses stack data structure as its fringe. So as we know that stack works on LIFO principle, last in first out method, the last node added to the fringe will get explored first. So let's now understand whatever concept we have discussed on this slide with the help of a diagram. So this is the diagram that I'll be using to explain depth first search. This is my tree data structure. These nodes represent the state and these branches represent the actions. And this is my stack, right? Over here, I'm taking A as my root node. So initially I'll be having A inside my stack. So let's start the traversal. So in the first iteration, we'll be popping out an element from the stack, and after popping out, we'll be getting A. We'll be getting A node. First of all, we'll check, is this the goal? If the condition is satisfied, the function would return a solution as state A, and if it's not, then A will be expanded. After expansion of A, we'll be getting the children of A as B and C. We'll be putting both of them in the stack. Again, the same operation would be performed. An element would be popped out from the stack, which will be the topmost element of the stack. Is C the goal? If it is the goal, then the function would return the C state. Otherwise, it would be expanded to get F and G. We'll be putting F and G inside our stack. So in the next iteration, G would be removed. It would be expanded if G is not the goal. As G is not having any children, nothing would add it to the fringe. Next time, similar thing would happen to F as well. If it's not the goal, it would be expanded. Nothing would be added to the stack. Now this, as you can see, that we have explored this entire sub branch, and after completely exploring this sub branch, what we are having in our stack, we are having B. So by this, the similar exploration of this branch would take place until we find a goal. If in the end, suppose if we expand all these nodes, if a goal state is not found, then the function would return no solution. So the pattern that you might have noticed, DFS has explored as far as down as possible, and if it doesn't find a goal, then it backtracks to explore other sub branches, and that's how the DFS exploration takes place. So now we have understood the traversal of DFS on a tree data structure. Now it's time to understand the algorithm corresponding to it. So this is my algorithm for depth first search. I have written it in a generalized manner, not in a program specific manner. Its main aim is to understand the working of depth first search. So this is my function DFS tree, which receives a parameter root, which is nothing but our root node. So inside our function, first of all, we have declared a stack, which is our frontier. And the first element to be added in our stack is our root node. So this was the initialization of our frontier. Now here the main working of DFS starts. This while loop. Now let's understand each line carefully. Over here you can see the condition. The while loop would continue to execute till the stack is not empty. So in the first iteration, as we have already added our root node inside our stack, so this condition would be true. There is something inside our stack. So in the first line inside the body of while loop, we are removing an element from the stack. Basically, we are popping an element from the stack. and how this removal would take place in LIFO manner, last in first out manner, which is the property of stack. And the removed element, or here we can say that the removed node, will be added in a node variable. Moving on further, now it's time to get the state corresponding to that node, and we have assigned that state inside the state variable. Now our previous discussion come into picture. First of all, we'll be checking, is this state a goal state? If the condition is true, then we'll be returning a solution corresponding to that node, the node that has given us this state. And suppose if this condition is not true, then what used to happen? We used to expand that node in order to get the child nodes, and those child nodes will be adding to the stack. And this entire while loop will keep on iterating till the stack is not empty or till we find a goal state, and the while loop would terminate. So in the end, after traversing the entire tree and not reaching a goal state, therefore we'll be returning no solution. So this was the algorithm of DFS, and that's how the algorithm works. So this was all about this video. In the next video, we'll be further exploring depth first search, and we'll be covering the following topics such as evaluation of DFS, its advantages and disadvantages, its applications, and we'll be comparing it with other search algorithms. So thanks for watching this video. See you in the next video.